Hi everyone, this is the solutions to the 2023 HSC Extension 2 Maths paper. In this video we're going to look at questions 11, 12 and 13. Question 11a. Solve the quadratic equation z squared minus 3z plus 4 is equal to 0, where z is a complex number. Give your answers in Cartesian form. So I'm just going to use the quadratic formula. Z is equal to minus b plus or minus the square root of b squared minus 4 times a times c, all over 2a, which is equal to 3 plus or minus the square root of 9 take away 16, which is negative 7, all over 2, which is equal to 3 halves plus or minus root 7 on 2i. 11b. Find the angle between the vectors a and b, giving your answer to the nearest degree. And so we know that cos theta will equal a dot b divided by the magnitude of a and magnitude of b, which is going to be equal to, so just doing the dot product between a and b, we get 1 times negative 1. I'm just multiplying these coefficients. Plus 2 times 4 is 8. Plus negative 3 times 2 is negative 6, all over the square root of 1 squared plus 2 squared plus negative 3 squared. And also multiplied by, now let's do b, the magnitude of b, the square root of negative 1 squared plus 4 squared plus 2 squared. And I'm just going to put that into the calculator, which is going to give me, just bear with me, negative 1 plus 8 minus 6 all over the square root of 14 and multiplied by the square root of 21, which gives me 0.058. And if I got my calculator in degrees, I do. So inverse cos of the answer, and we want it to the nearest degree. Theta is equal to 86.7 degrees, so that's approximately equal to 87 degrees. 11c. Find a vector equation of the line through the points A and B. So we're going to need a direction vector. I'm just going to work out AB. So that will be 0 take away negative 3, 2 take away 1, and 3 take away 5. And so our equation is going to be either one of those points, so negative 3, 1, 5, plus lambda, and then our direction vector. I'm going to call that R. 11d. The quadrilaterals ABCD and ABEF are parallelograms. By considering the vector AB, show that CDFE is also a parallelogram. Well, let's see if we can draw this. So we've got a parallelogram A, B, C, D, and then we've got another parallelogram A, B, E, F. What could that look like? A, B. Let's go this way. E, F. By considering this vector AB, show that CD, let's draw that in a different colour, CDF, I see, E, is also a parallelogram. Okay, so let's start with AB. Well, we know that AB is equal to DC, and we also know that AB is equal to FE. Therefore, DC is equal to FE. So that gives us one part. So this is parallel to this, and it's actually equal. Now we need to consider FD and EC. So how can we do that? I think we might make a vector equation. So we'll say, Okay, df is equal to dA plus AF, and similarly CE, that's here, is equal to CB plus BE, but we know that dA is equal to CB and AF is equal to BE, and so DF is equal to CB plus BE, which makes it equal to CE. And so since we have got opposite sides equal and parallel, therefore CDFE is a parallelogram. (11e) Particle moves in simple harmonic motion described by this equation. Find the period and central point of the motion. So we know that the formula for simple harmonic motion is acceleration is equal to negative n squared x minus c. That is the centre of the motion. So the centre of the motion in this case is x is equal to 4. And we know the period is equal to 2 pi on n. And in this case, n is 3. So our period is 2 pi on 3. It's a nice easy question. And F. Find the integral between 0 and 2 of 5x minus 3 all over x plus 1 multiplied by x minus 3. So this is obviously partial fractions. So we're going to let 5x minus 3 over x plus 1 multiplied by x minus 3 equal a over x plus 1 plus b over x minus 3, which is equal to a times x minus 3 plus b times x plus 1 all over x plus 1 x minus 3, which means that 5x minus 3 must be equivalent to a x minus 3 plus b x plus 1. So we'll let x equal 3. So that gives us 15, take away 3 is 12, is equal to 4b. So therefore b is equal to 3. And then we'll let x equal negative 1. So we've got negative 5, negative 8 is equal to negative 4a. Therefore a is equal to 2. That can be written as 2 ln x plus 1 plus 3 ln x minus 3. And our limits are 0 and 2. So substituting the 2 in, we get 2 ln 3 plus 3 ln negative 1. Take away, brackets, 2 ln 1 plus 3 ln negative 3, which is equal to 2 ln 3. Now, we have absolute values here, so this is the same as 3 ln 1, which of course is 0. Take away 2 ln 1, that's also 0. And then take away 3 ln, and absolute value of negative 3 is 3. And our answer is negative ln 3. Question 12, prove that root 23 is irrational. So of course we're going to start by assuming that root 23 is rational, which means of course that root 23 can be written in the form a over b, where a and b are whole numbers and b is not equal to 0. And further, a and b are co-prime, which means that they have no common factors. Or we could use the word irreducible. Okay, If this is true, we can square both sides, and that gives us 23 is equal to a squared over b squared, which means that 23b squared is equal to a squared. Which means that 23 is a factor of a squared. Now, since 23 is prime, then 23 is also a factor of a, which means that we can write a as 23m, 23m, where m is an integer. Therefore, 23b squared is equal to 23m all squared. 23b squared is equal to 23 squared m squared. Divide both sides by 23, and we have b squared is equal to 23 m squared. Therefore, 23 is a factor of b squared, and since 23 is prime, therefore 23 is a factor of b. And so a and b have a common factor, and I've run out of room. Therefore, they are not co-prime. Therefore, it is a contradiction. Therefore, root 23 is irrational. And you will need to write all of that. Question 12b. Prove that for all real numbers x and y, where x squared plus y squared is not equal to 0, x plus y all squared all over x squared plus y squared is less than or equal to 2. A couple of different ways to do this, but I'm going to start with required to prove statement that x plus y all squared all over x squared plus y squared minus 2 is less than or equal to 0. So start with the left-hand side, x plus y all squared all over x squared plus y squared minus 2 is equal to x squared plus 2xy plus y squared minus 2 lots of x squared plus y squared all over x squared plus y squared is equal to x squared, take 2x squared is negative x squared plus 2xy minus y squared all over x squared plus y squared, which is equal to negative x squared minus 2xy plus y squared all over x squared plus y squared, which is equal to negative x minus y all squared over x squared plus y squared, which is less than or equal to 0. So therefore is proved. 12c. An object with mass m kilograms slides down a smooth inclined plane with velocity v of t. T is the time in seconds after the object started sliding down the plane. The inclined plane makes an angle of theta with the horizontal. Normal reaction force is r. Acceleration due to gravity is g. No other forces act on the object. Vectors I and j are unit vectors parallel and perpendicular to the plane. Part 1, show the resultant force on the object is this. Right, so let's start by drawing up this triangle and resolving this weight force. Simple trig. If this is theta, then this in here is theta. And so perpendicular to the plane we have mg cos theta, and parallel to the plane we have mg sine theta. Now, the reaction force will be equal to mg cos theta j, and force down the plane will be negative, because it's against the motion, mg sine theta I. Now, quick tip, if you're drawing all over this diagram, that doesn't appear in your answer booklet, does it? So you're going to need to do a quick sketch of the diagram. Part 2, given that the object initially is at rest, find its velocity v of t in terms of g, theta, t, and I. So we had F was equal to negative mg sine theta I. So F is equal to ma, negative sine theta. And so A is equal to negative G sine theta. So we want V of t, so that's dV dt is equal to negative G sine theta. V is equal to negative gt sine theta plus C. And we know initially it's at rest, so when t is 0, V is 0, and therefore C is 0. Therefore, V of t is equal to negative gt sine theta I. Question 12D. Find the cube roots of 2 minus 2i. Give your answer in exponential form. So let's start by changing this into exponential form. So if we've got, say, z is equal to 2 minus 2i, then mod z will equal the square root of 4 plus 4, which is root 8. And then arg z will be equal to inverse tan of negative 2 on 2. Quick diagram. Where is this? 2 minus 2i, it's down in here. And we want a negative angle, so it'll be equal to negative pi on 4. And so z is equal to root 8 e to the negative pi on 4 I. Now let's let another complex number w cubed equal root 8 e to the negative pi on 4 I. Now we know that the modulus of w will be the cube root of the square root of 8, which is root 2. And we know that the argument, I'm going to call it theta or 3 theta, will be equal to negative pi on 4 plus 2k pi, for k is equal to 0 or plus or minus 1. Theta is equal to negative pi on 12 plus 2k pi on 3. Okay, when k is equal to 0, we have w1 is going to be equal to root 2 e to the negative pi on 12i. When k is equal to 1, w2 will equal root 2 e to the, what do we got here, negative pi on 12 plus 2 pi over 3i, which is equal to root 2e. Got 12, negative 1 plus 8, 7 pi. Okay, and then when k is equal to negative 1, w3 is equal to root 2 e to the negative pi on 12 minus 2 pi on 3i, which is equal to root 2 e. We've got 12 on the bottom, we've got negative 1, take away 8, it's minus 9, minus 9 pi I, or root 2 e to the negative 3 pi on 4 I. 12e. The complex number 2 plus I is a zero of the polynomial pz, where c and d are real numbers. Part 1, explain why 2 minus I is also a zero of the polynomial. It's a nice easy question, isn't it? So we have a real polynomial here because c and d are real numbers. All the coefficients are real. So since, this is part 1, p of z has real coefficients, then complex roots occur in conjugate pairs. Therefore, since 2 plus I is a root, 2 minus I must also be a root. Also be a root. Part 2, find the remaining zeros of the polynomial. Now you can do this via division. It's actually usually easier to do it by sum and product of the roots. So we know that we have 2 plus I and 2 minus I, and then we'll call the roots, what is it, 2 power 4? Yep, alpha and beta. Right, so some of the roots would be alpha plus beta plus 2 plus I plus 2 minus I will equal negative b on a, so 3. So alpha plus beta plus 4 is equal to 3, so it's equal to negative 1. There's our first equation. Product of the roots. 2 plus I multiplied by 2 minus I multiplied by alpha beta would be equal to minus b c minus d e. E on a, so negative 30. Gives me 4 plus 1 alpha beta is equal to negative 30. Alpha beta is equal to negative 30 divided by 5. 30 divided by 5 is negative 6, and there's our second equation. Right, just coming over here, I'm going to let alpha equal minus 6 over beta, and substituting into 1 gets negative 6 over beta plus beta is equal to negative 1. Negative 6 plus beta squared all over beta is equal to negative 1. Go to the next page. Gives us negative 6 plus beta squared is equal to minus beta. Beta squared plus beta minus 6 is equal to 0. Factorize. Beta, we want factors of 6. That gives 1, 3, and 2, plus 3 minus 2. So beta is equal to 2 and negative 3. Now, of course, they are the other two roots. So the roots are 2 plus I, 2 minus I, 2, and negative 3. 15a, find the integral of 1 minus x all over the square root of 5 minus 4x minus x squared dx. Now initially I thought we had to complete the square on the denominator, and we will do that, but not to start with. We need to start with the reverse chain rule. So looking at that denominator, the derivative there is negative 4 minus 2x. And I've got most of that up on the numerator, but I'm actually going to look for negative 2 take x, just to make things a little bit simpler. So let's start 1 minus x all over the square root of 5 minus 4x minus x squared dx. And let's make this. So we want negative 2 take x. Now let's adjust that so we haven't changed anything. All over square root of 5 minus 4x minus x squared dx. Up here equals, split it up, negative 2 take x all over square root of 5 minus 4x minus x squared dx plus 3 lots of 1 over the square root of 5 minus 4x minus x squared, which is equal to 5 minus 4x minus x squared to the power of half divided by a half divided by the derivative of this, which is negative 4 minus 2x. And we've got most of that there, we're just missing a 2. Plus 3. Now we need to complete the square. Now you're going to think I'm crazy, but this is the way that I do it. I'm going to factorize the negative out. It just helps me make sure I don't make a mistake, basically. X squared plus 4x minus 5. You don't have to do it this way. Equals square root 5 minus 4x minus x squared plus 3 integral 1 over square root negative. We've got x squared plus 4x, complete the square, plus 4 take away 9. which is equal to square root of 5 take 4x minus x squared plus 3 integral, let's bring that dx on top, all over square root. Let's tidy this up. You can see the negative here and the negative here, so that's going to be 9 take away, and then completing the square here, x plus 2 all squared equals square root of 5 take 4x minus x squared plus 3 inverse sine of x plus 2 over 3 plus c. Question 13b, part 1, show that k squared minus 2k minus 3 is greater than or equal to 0 for k is greater than or equal to 3. So let's complete the square. Plus 1 take away 4, which is equal to k minus 1 all squared minus 4. A quick sketch. We have got a turning point or a minimum point at 1, negative 4, which is here, and concave up. Not really concerned about the left-hand side here. We're only interested in this part. What is this coordinate here? Let's substitute in 3. So when k is equal to 3, we have got 3 take 1 all squared take 4, which is 2 squared, which is 0. So that is 3. So we can see from the diagram, because this is k, that when k is greater than or equal to 3, this is above the x-axis, so it is greater than or equal to 0. Part 2, hence or otherwise use mathematical induction to prove that 2n is greater than or equal to n squared minus 2 for all integers n greater than or equal to 3. So we'll start with n is equal to 3. So our right-hand side, I meant to do left-hand side, is equal to 9 take away 2, which is 7. And our left-hand side is equal to 2 cubed, which is 8. And 8 is greater than or equal to 7, therefore true for n is equal to 3. Now let's assume it's true for n is equal to k. In other words, 2 to the k is greater than or equal to k squared minus 2. And now we need to prove it for n is equal to k plus 1. So we are required to prove that 2 to the k plus 1 is greater than or equal to k plus 1 all squared minus 2. So starting from the left-hand side, we have 2 to the k plus 1 is equal to 2 lots of 2 to the k. I'm going to use our assumption. This means that it is greater than or equal to 2 lots of k squared minus 2. Which is equal to 2k squared minus 4. Now we're going to use this part here. They gave it to us in part 1, so obviously they want us to use that, or it's a hint. So I'm going to make that out of this expression here. So 2k squared minus 4, it's k squared minus 2k minus 3 plus k squared, gives me the 2k squared, plus 2k minus 1. All right, now we know that this part here is greater than 0, so greater than or equal to 0 plus k squared plus 2k minus 1, which is equal to k squared plus 2k plus 1 minus 2, which is equal to k plus 1 all squared minus 2, therefore true for n equals k plus 1. Therefore, by the principle of mathematical induction, true for all n. 13c. A particle of mass 1 kilogram is projected from the origin with a speed of 40 meters per second at an angle of 30 degrees to the horizontal plane. Use the information above to show the initial velocity of the particles given by the vector v0 equals 20 root 3 and 20. Okay, so we're just going to find the components of velocity. This one here is going to be 40 sine 30, and this one here will be 40 cos 30. And so V naught will be equal to 40 times root 3 on 2, and then 40 times a half, which is equal to 20 root 3, 20. The forces acting on the particle are gravity and air resistance. Air resistance is proportional to the velocity vector with a constant of proportionality 4. And let the acceleration due to gravity be 10. Position vector of the particle at time t seconds is r of t, velocity vector is v of t. Prove this. All right, I find it easier to work in two systems just for notation. So I'm going to start off with the horizontal system and try and prove this part here. So we'll start with A. So acceleration is equal to, so horizontally we have no gravity, but we do have air resistance and it works against the motion. So it's going to be minus 4v. Remember, mass was equal to 1. Now we want this in terms of t, so I'm going to do dv dt. Put it upside down. dt dv is equal to negative 1/4, 1 over 4v actually be better. So t is equal to negative 1/4 integral of 1 over v dv is equal to negative 1/4 ln v plus c. Now at time is equal to 0, velocity is equal to 20 root 3, so 0 is equal to negative 1/4 ln of 20 root 3 plus c, and so c is equal to 1/4 ln 20 root 3, which means that t will equal, I'm just going to have a quick check here, I've got negative power, so I'm going to bring out the negative 1/4, and then ln v over 20 root 3. I've done that fairly quickly. Negative 4t is equal to ln v over 20 root 3. I'm not going to go to a new slide, so it's going to get a little bit messy. Just come over here. E to the negative 4t is equal to v over 20 root 3, and therefore v is equal to 20 root 3 e to the negative 4t. Now let's work in the vertical system. So we have a is equal to minus 10, take away 4v. Again, we want t, so let's do dv dt is equal to negative 10 minus 4v, and turn it upside down, dt dv is equal to negative 1 over 10 plus 4v. So t is equal to negative integral of 1 over 10 plus 4v dv, which is equal to negative ln 10 plus 4v divided by 4 plus c. Subbing in, we will get 0 is equal to negative ln 10 plus 80 all over 4 plus c, and so c will equal ln 90 over 4. Therefore, t is equal to, again we've got a negative power here, negative 1/4 ln 10 plus 4v divided by 90 equals negative 4t is equal to ln, cancel something out here, I can, let's factorize it, we're going to have 5 plus 2v all over 90, just up and over here, e to the negative 4t is equal to 5 plus 2v all over 45. 45 e to the negative 4t is equal to 5 plus 2v. I'm running out of room. 2v is equal to 45 e to the negative 4t. Take away 5, and pretty much we've just got to divide by 2. I'll let you do that. 3. Now we need to prove the displacement vector. And again, I'm going to work in two systems. So horizontal system. We start with v is equal to 20 root 3 e to the negative 4t. So dx dt is equal to 20 root 3 e to the negative 4t. X is equal to 20 root 3 integral e to the negative 4t dt, which is equal to 20 root 3 e to the negative 4t divided by negative 4, got ahead of myself there, plus c, which is equal to negative 5 root 3 e to the negative 4t plus c. Now initially, so at t is equal to 0, x is equal to 0, it's projected from the origin. So what does that mean? C will equal 5 root 3. Therefore, x is equal to 5 root 3, take 5 root 3 e to the negative 4t, and then just need to factorise it. Now let's work in the vertical system. So we have v is equal to 45 on 2, e to the negative 4t minus 5 on 2, and we want dy dt, so that will equal, I can bring that 5 over 2, 9 e to the negative 4t, take 1, and so y is equal to 5 halves integral 9 e to the negative 4t, take 1 dt is equal to 5 halves, brackets 9 e to the negative 4t on negative 4 minus t plus c. At t is equal to 0, y is equal to 0, and so c is going to be equal to, that'll be 0, that'll be 1, it's going to be positive, 5 9s are 45 over 8. That looks nice, doesn't it? Okay, therefore, y will equal 5 halves negative 9 e to the negative 4t on 4 minus t plus 45 on 8. Probably not expecting much more algebra from me to get to this point. But let's take out, common factor. Oh, I can see that there. All right, 45 over 8. Here I've got negative e to the negative 4t plus 1, and then we're taking this out of the brackets, which will give me minus 5t on 2. Yeah, that's close enough. And part 4, the graphs y equals 1 minus e to the negative 4x and y equals 4x on 9 are given in the diagram. Using the diagram, find the horizontal range of the particle, giving your answer rounded to 1 decimal place. All right, so if we want the range, remember our particle is going up and coming down, and we have this equation here for the vertical path. So we want to know when that's equal to 0, basically. So 0 is equal to 45 on 8, 1 minus e to the negative 4t minus 5t on 2. And so 45 on 8, 1 minus e to the negative 4t is equal to 5t on 2. We can do some cancelling here. So 2 goes into 8 4 times, 5 goes into 45 9 times. So we have got 1 minus e to the negative 4t is equal to 4t on 9. And that just happens to be the two graphs that we have here. So we know that the point of intersection, so t in this case, is approximately equal to 2.25. Now substituting that into our equation for the horizontal distance, so x, it's actually, let's do x. X of 2.25 is going to be equal to 5 root 3, 1 minus e to the negative 4 times 2.25. And if you put that in your calculator, you get 8.7 meters. In our next video, we'll cover questions 14, 15, and 16.